What the internet anyway? So we talk about being online all the time. We connect to the Wi-Fi, we use our data, we send files, we stream videos. It's just a part of life. But have you ever stopped to think about what's actually happening behind the scenes? It's not just one giant magical cloud, it's a complex web of different types of networks, all working together. Understanding these networks is actually pretty key to understanding the tech we use every single day. It's the difference between knowing your phone and knowing it works. Each network type is basically a different tool for a different job. Think of it like this. You wouldn't use a sledgehammer to hang a picture frame, right? Same idea here. Some networks are designed to be super fast and cover a small space, like your apartment. Others are built to connect entire cities or even span the globe. It all comes down to a few key things: how far the signal needs to reach, who owns and manages the hardware, the specific technology being used, and what you're actually trying to accomplish with it. In this video, we're going to break down the 4 major types of computer networks you interact with, probably without even realizing it. We'll look at what makes each one unique, where you'd find them, and why they matter. By the end, you'll have a much clearer picture of the invisible infrastructure that powers our connected world. It's actually pretty fascinating when you dive into it. So, let's get into it. Alright, let's start with the one you're probably using right this second. The LAN, or Local Area Network. This is your home base, your digital command center. A LAN is a collection of devices connected together in one physical location, like a home, an office building, or a school. The key word here is local. We're talking about a relatively small geographical area. Think about your home Wi-Fi network. Your laptop, your phone, your smart TV, your printer, they're all talking to each other through your router. That's a classic LAN. The biggest advantages of a LAN are speed and cost. Because the devices are physically close to each other, the connections can be incredibly fast and responsive. Transferring a huge video file from your laptop to your desktop over your home network is way faster than trying to upload it to the cloud and download it again. This is because the data doesn't have to travel across the country. It just has to zip across the room. The hardware, like routers, switches, and Ethernet cables, is also relatively inexpensive and easy for a single person or organization to own and manage. So, the use cases are pretty straightforward. It's for sharing resources in a contained environment. In an office, it's what lets everyone connect to the same server or use the same central printer without having to physically plug in every time. At home, it's what lets you stream a movie from your media server to your TV or play a multiplayer game with your family in the same house with minimal lag. It's the foundation, the private little bubble of connectivity that we build all our other online experiences on top of. Essentially, if you have a bunch of devices under one roof that need to communicate with each other or share a single internet connection, you're looking at a LAN. It's high speed, it's low cost for what it does, and it's privately owned. You control it. It's the most common and fundamental type of network, and it's the building block for almost everything else we're going to talk about. It's the personal bubble for your tech. So what happens when you need to connect devices that aren't in the same building? What if you need to connect your office in New York with your office in Tokyo? That's where the WAN, or Wide Area Network, comes in. A WAN spans a very large geographical area, like a state, a country, or even the entire planet. It's not one single network, but a network of networks. It's what connects multiple LANs together over long distances, letting them communicate as if they were one. The most famous and largest one in the world is, you guessed it, the Internet. It's a massive, sprawling web of interconnected networks that allows your home LAN to talk to a server's LAN halfway across the globe. But WANs aren't just the internet. A large corporation with offices in multiple cities will use a private WAN to connect all its locations. Think about bank ATMs. They all need to connect back to a central bank database, regardless of where they are in the country. That's another perfect example of a WAN in action, ensuring every transaction is secure and synced up. Now there's a trade-off. Because the data has to travel over such vast distances, through fiber optic cables under the ocean, via satellites, across telephone lines, WANs are generally slower and have higher latency than LANs. It just takes longer for the signal to get from point A to point B. They are also much more complex and expensive to set up and maintain. Typically, WANs are not owned by a single person or company. Instead, they are often managed by multiple telecommunication companies or service providers who lease their infrastructure. So, a WAN's purpose is all about long-distance communication and resource sharing on a massive scale. It's what makes our globalized world possible. It's how you can send an email to a colleague overseas, watch a video hosted on a server in another country, or access your company's internal files while working from a hotel. It's the connective tissue that links all our little local networks into one giant global conversation. Without WANs, every LAN would be an isolated island. Okay, so we've covered the small scale with LANs and the global scale with WANs. But what about the space in between? What if you need to connect several buildings across a university campus, or link up all the government offices within a single city? That's the sweet spot for the MAN, or Metropolitan Area Network. As the name suggests, a MAN is a network that spans a physical area larger than a LAN but smaller than a WAN, typically covering a city or a large campus. Think of a MAN as a big, beefed-up LAN, or a smaller, more localized WAN. It's designed to be the high-speed backbone for a specific region. For example, a large university might use a MAN to connect the libraries, lecture halls, and dorms across its entire campus. This allows for a fast, seamless connection for thousands of students and faculty. Another great example is a city providing free public Wi-Fi in its downtown area, or connecting all its traffic lights to a central control system. That infrastructure is a MAN. In terms of technology and ownership, MANs are interesting. They often use high-speed fiber optic cables to link different locations, providing much faster speeds than a typical WAN connection over the same distance. They're usually not owned by a single individual, but are managed by a large organization, a consortium of users, or a single network provider who sells the service to the public or other businesses. It's a single, cohesive network for an entire metropolitan area, rather than a jumble of different LANs connected through a WAN. So, the key differentiator for a MAN is its scale and purpose. It's bigger than an office, but smaller than a country. It's built to provide high-speed connectivity to multiple locations within a concentrated area. You'll see them in the form of campus networks, citywide government networks, or the infrastructure used by internet service providers to serve an entire community. It's the network that bridges the gap, creating a connected digital city. Finally, let's zoom all the way in, even smaller than a LAN, to the most personal network of all, the PAN, or Personal Area Network. This is the network that exists within your immediate personal space, typically within a range of just a few meters. It's designed for one thing, connecting your own personal gadgets together without the mess of wires. If you've ever paired your phone to your car, or used wireless headphones, you've created and used a PAN. The dominant technology here is, of course, Bluetooth. It's a low-power, short-range wireless standard that's perfect for this kind of device-to-device communication. When your smartwatch syncs notifications from your phone, that's a PAN. When you use a wireless mouse or keyboard with your computer, that's a PAN. It's a temporary, ad hoc network that you create on the fly just by bringing your devices close to each other. It's all about convenience and eliminating cable clutter. PANs can also be wired. Remember connecting your old MP3 player or digital camera to your computer with a USB cable to transfer files? That's technically a wired PAN. The computer and the connected device form a tiny two-node network for the sole purpose of sharing data. The defining feature isn't the technology, but the scale and purpose. It's for one person, connecting their own devices within arm's reach. So while LANs connect a home or office and WANs connect the world, PANs connect the tech you carry on your person. They are simple, low power, and designed for short-range tasks. Think wireless headphones, fitness trackers, smartwatches, wireless keyboards, and connecting your phone to your car's infotainment system. It's the technology that creates a small, personal bubble of connectivity around you, making all your gadgets work together seamlessly. It's your own personal tech ecosystem. So there you have it. 4 main types of networks, each built for a very specific job. You've got the PAN for your personal gadgets in your immediate bubble, the LAN for connecting everything in your home or office, the MAN for linking up an entire campus or city, and the WAN for connecting everything across the globe. From the Bluetooth headphones in your ears to the World Wide Web at your fingertips, you're constantly moving between these different layers of connectivity. It's a pretty elegant system when you lay it all out. Each type is a crucial piece of the puzzle. Without PANs, we'd be tangled in wires. Without LANs, sharing files at home or in the office would be a nightmare. Without MANs, creating unified citywide services would be incredibly difficult. And without WANs, well, there would be no internet as we know it. They all work together to create the seamless, connected experience we often take for granted. The lines between them can sometimes blur, but the core principles of range, speed, and ownership define their roles. So, next time you connect your phone to your car, log on to the office Wi-Fi or video call a friend on the other side of the world. Take a second to think about which network, or combination of networks, is making that possible. It's a cool way to appreciate the incredible engineering that underpins our digital lives. Hopefully, this gives you a better map of that invisible world. Thanks for watching.